Again, thank you everyone for joining. We will be doing day 3 session today. GitHub link, it's already shared with you. I'm going to share it again. Just a few minutes before I pushed the new changes, which contains day 3 details. Mostly it will, let's see, let me send the link. My computer is running slow. Let me create a few of the applications. I guess able to hear me well without any interruption as such.
Yes.
Yes, no, yes, okay. So here is the GitHub link again. It has the 3 kind of slides, notes, queries. So every iteration, I've been re-editing the previous day series as well, because some of the topics that we covered, the one that we haven't been covered, so I'm remodifying it. So you will see some slight changes in day 1, day 2 as well. And now I guess we can start looking into it. So I'm going to share my screen. Hi, Shannon. Hi, Ray. So here. So day 1, day 2, day 3. Although I just renamed it something like more, DDL commands and more, DML commands and more, because it does contain a lot of other information. In day 3, specifically, let's go into day 3. This might be because of I'm connecting to the VPN. It's a little bit slower. Okay, so here day 3, README file, and there is also a SQL file. So README file is just like a slide information, and then SQL file contains all the SQL queries that we'll be going through. So today we will be revisiting indexes. We will be covering again, I need to change the title of that. I copy pasted it. DML queries and all of the DML queries from there. And then we'll go through all these nodes as well. So we will begin with basically directly on database side, and then I will explain each of those stuff. Right now, we're just dropping the database if it exists. And if it exists, is always a good habit to have it. And if you guys have any questions, feel free to ask. So we create a database, we will create a one table and we'll create a procedure. So right now, the goal is to create at least 500,000 of records in a single table. And then we will create index in that table and we'll go through the execution time that it takes. So there's a time complexity. We'll just create a very simple table. And again, if you have any question, feel free to ask. So this is just a simple table in which we have to select the default table database that we just created, which is our, let's say, I have so many things here. This is my local machine, and let's see, it's already exists. Here. So you can either double click on it to select it, or you can also do use and the database name. So what it does is it makes that database as your current instance. So I double clicked on it to select it. Now I will run the data table creation query, and we created the table. So now if I refresh this, I will be able to see this table which exists within this database. I'm writing procedure right now. We don't have to, we will be covering procedure functions later. I'm writing procedure right now just to, not to manually add all of the records, that 500,000 records manually. I will be using procedure to automate that process and add those 500,000 records. Um, and this is similar to most of the relational databases. There might be slight changes in how you define procedure based on whether you're using MySQL Server, whether you're using Postgres, Microsoft SQL Server, Oracle, but the inline definitions will be pretty much same. So let's see. So I'm checking if the procedure already exists. If not, then what we'll do is we'll create procedure. Before that, MySQL needs, because when you define procedure, MySQL needs a way of finding where that procedure is ending. Mostly, if you see the MySQL in database, it's mostly in any other programming languages as well. They terminate with semicolon. And this MySQL database, it's not a full-fledged programming language, but still you can define procedure, function, triggers with a slight addition to it. Like you have to manually define when you are starting your procedure function and at what line it is ending. So for that purpose, we use delimiter. Right now, I'm using double /. You can use delimiter anything. You can use hash, $, hash, either delimiter is fine. So as soon as I define this delimiter, if I do end here, I will say it ends here. So means in between these two, start tag and end tag, I will define my procedure. So I wrote this first statement saying create a procedure, and then procedure name, and then procedure start with begin. It's very weird because I guess you might have used Python or other programming languages. It's not like the same. This is a database engine. It is mostly designed to consume SQL statement, but they did some additional changes. Now it is also able to do run functions and procedures. So that's why it has a little bit weird syntax, but bear with me. So we just said begin. Now we'll do declare and to while. So here I went to, let me see, 3. Okay, we'll enter this many records, almost 500,000. And 2. This is insert query. Again, insert query is a DML query. We will go through that again in detail once I execute this. We have EMP ID. Now I'm manually inserting EMP ID because although it is primary key, I didn't say database engine auto increment it. Suppose if I do auto increment here, then I don't have to, so if I do auto increment here, then I don't have to define EMP ID and add specific value to it because database behind the scene will take care of it. But in our scenario, we didn't say auto increment while creating the table. So that's why I'm adding it manually. So we are adding EMP ID, first name, last name, email, and department. Again, I'm defining the column names in which I'm adding the values. Now, select. So in first column, I'm adding I, which will be the value, which will increment starting from 1. So it will start from 1 till it is less than 500,000 value. And then out name and I value. Okay, so this statement basically says insert into basically the table name, which is IFH EMP. And then I'm also defining all of the column names. If I don't define column names, then I will have to follow the exact sequence in which those columns are defined, which basically you can also see in here. When you click on the table name, you will see all the column names and their position in the table. This is very fixed position. It's not like it's a dynamic. It follows that same sequence when we add values. I can change this to this as well because I'm putting the column name. So I can put this here and then tell database to take the last value as IFH ID. That is definitely possible. But when you are inserting a value and if you don't define the column names, so I'm inserting the values and I'm not defining the column names, then I will have to insert in the sequence in which the column is defined while creating the database table. Means I will have to do ID first, then first name, last name, right? Then the email and the department. So I will have to follow that exact sequence in which it was defined while it was created. So this is insert query, and then we will do I is equal to. So we'll increment I because we want to increase the loop and execute that loop again and again till we satisfy this condition and exit out of loop. So we did this, and we'll do end while, and we'll commit this code and we'll end the statement, and then I will change delimiter back again to semicolon. So I changed the limiter back to semicolon for a reason, because I again want to database to come back to its normal position where it uses semicolon as its delimiter. So yeah, let's see. And this concat function is basically concating the string. This is string. This is a static string to the whatever the value of I will be. So right now it's starting with 1. So the next iteration it will be 2. In the second iteration it will be 2. In the third iteration it will be 3. Because I'm asking here to increment by 1 in every iteration. So in Python, you might have did something like this, where you don't have to define the increment, but in databases, it doesn't accept that because it's still very primitive. So this is this. We wrote this procedure. And then after that, we will call this procedure, which is add dummy records. So again, so procedures and functions are pretty much same. In procedure, you basically don't return the value, but in function, you can return a value. That's the only difference between procedures and function. Let's see. This. Okay, so now we did this. We will create this procedure. So we created this procedure. Now, although I created this procedure, but I haven't ran it. So means, let's see. Our table is this one. So our table has 0 records in it. Now what I will do is I will run this procedure. So the procedure is running. You see it's executing query. So it is executing now. It's adding multiple records in the table. Once it's done, we'll go back to the procedure. So to repeat, we created the table, which is IFH employee table. We have IMP ID, employee ID, which is primary key. We have first name, last name, email, department. I'm using varchar here. You should be always using varchar or nvarchar. Oracle and other relational database system also uses nvarchar, which is basically for Unicode. Unicode is this. This is there's ASCII, American Standard for information interchange. Means every values you see in your keyboard has some number associated with it to transfer into to the hexadecimal, then basically binary in machine understandable code. So Unicode came into picture for multilingual characters and character set. English has very specific character set, but there are multiple other languages. For that purpose, Unicode come into existence. It's a consortium comprised of many big companies, because before Microsoft and other big vendors, they used to have their own character set. You might have seen in previous, like in 1970s, 80s, there are keyboards with a really different wide range of symbols, and every manufacturer had some different sort of variation. So to avoid that, Unicode came into existence, and they started putting together the list of standards that every company should follow. There are still some companies which don't follow. That's a different case, but it defines the standards for specifically to include the multilingual characters and character set symbols into the translation that when we do or add into database in programming languages and all that. Unicode is a standard, is a character set, and you might also heard of UTF-8. So UTF-8 is a part of Unicode. So it's basically pretty much same, except how the length of it's like 8 byte to 16 byte length. That's the only difference in that. But UTF-8 is also compatible with all the foreign languages as well. So it is still executing. Let's see how much time it takes. We will let it insert. This is just the procedure. In your lifetime, I would say you should not be using procedures function in database unless you need to do something like this. Or you can also use Excel to create sample records. You can use Excel functions, and then you can also import it, do the insert query using that. So once it's done, we will go through the execution plan. So with this, we will look into two algorithms. Last time we discussed binary search tree and B tree. Now here, when I said primary key, behind the scene, it is going to use that index. So if I refresh here on this table, if I look into indexes, there is a primary key index. And for this primary key index, the type, which is algorithm used to define that index, is B tree, which is B for balanced tree, and BST, which is another algorithm, which is binary search tree. So this is not for binary, this is for balanced, because this algorithm balances itself automatically. This is how it is defined. So that's why it's called as a balanced tree. There is a B plus tree as well, but once this is done, we will first run the query, and then we'll go into the algorithm steps, how it works. It's still executing. You will find this again. Let's see. So here I added some notes that you can refer to. Binary tree, we'll go into that again. Binary search tree has complexity of big O of log n. Big O is basically a representation to show time complexity. There's also, you can represent the space complexity as well. Logarithmic time is basically every iteration, it divides the length of array or size of data set into half. And then for the unbalanced binary search tree, it has a complexity of ON. ON, big O of n is basically the number of record it has. Suppose it has 100 records, that means it will go through each of that value. If it has like 1,000, it will go through each of the value. If it has million, it will go through each of them. So that's a ON. Whatever that number is, it has to go through each of that value. That's why it's called as a big O of n, which is for unbalanced binary search tree. Let's see if it's executed. So let's do this. I will still write some of the queries here. Again, I'm selecting all the records where it matches the ID is equal to, suppose I say 5. That's one query. table, which is IFHEMP, it's still executing. Okay. Oh, it's completed. So we just inserted 500,000 records. So if I go through this, I will just count. This is really bad practice to do the count technically, but let's see. So we have one record less than 500,000, basically because we did here I less than 500,000. If I do I less than equal to, then it will have exact values, and as we started with 1. So note here, I did count star. Instead, I should be using only IFH ID column. So the execution time for this, if you look at the bottom, it took 0.061 second for this. But if I do count on just ID record, let's see, ID, oh, that's an EMP ID, not IFH ID. So if I do just count, you will see there's a huge difference between how much time it took now. It's like almost half than what it took previously. So whenever you need to run such kind of things, you know, the summation functions, aggregates, count, if you really don't need other columns, you should be using the column which has index built on it. So right now we have index built on employee ID key. So if I just use that, that means I'm taking the benefit of that index. To really see, let's say, if I do explain here, so explain, you will find this mechanism in every relational database. When you do explain, it tells you how it is executing, how that database engine is executing that query. So when I did explain on this, it will say type index. This type is basically saying that what it is using. It is still, it has to go through all of the rows because it is doing the count, but it is still taking the benefit of index, right? So because of that index, it was able to execute much faster than when I did star. Star means take everything basically. So same here, if I run this query, now, again, this is EMP ID. So if I run this, so the execution time it took is like 00063. And if I do explain on this, it will tell us how many records it's went through. So it is running in constant time. So if you look at this type column, it is running in constant time. And constant time is always better than the range and then all of the columns. So there's all of the data values. There is a range, which is specific range between the whole large data set. And there's a constant time, which is directly points to the specific value. So this is doing in a constant time because we have index on this IMP employee ID column. So if you look at the rows, the database engine went through only one row to get to that answer. Means it's the best. This is the best thing you can do in database, and that's the benefit of index. Now, this employee ID column has index on it, and it took constant time, went through only one row to find this record rather than going through each of the records, each of the values. It found that in constant time. Now, if I do same thing for the first name, here, if you see this is name 5, that means this name 5 exists at 5th position in the sequence. It took 0.329 second. And if I do explain on this, this is very bad because to find this record, it has to it had to go through all of the data values. It scanned like almost 500,000 rows. So if you see this row column, the value it has, it scanned through almost 500,000 rows, although in sequence it is at 5th position. So when you don't have an index, it doesn't matter where that value exists, it will still go through all of the rows in the database table. So now what we will do is, so we just looked at how many rows it went through. It is going through all of the rows almost. And then the execution time it took. So without explain, if I run this, the execution time for this now it is 0.429 seconds. So that is a little bit changing because also it depends on my computer. My computer already running a lot of applications, and that's why there's a slight effect on that. So what we will do now is we will create index on the first name column. So we'll create index. We will name index as, so the best practice is to name your index. It again varies institution to institution. I usually do index IX, the table name, which is IFH EMP, and then the on which column I'm doing. So I'm doing it on the first name column. That's my index name. On, this is IFH EMP table, and then I'm using first name column. And then here, the funny thing is I can define whether I want ascending, descending, and also I can define what algorithm it can use. So by default, it uses binary, not binary tree, it uses a balanced tree, which is B tree. You can also ask database engine to use hash to create this index. Right now, we'll just keep it by default one. So I'm telling database engine to create index with this name on IFH employee table on the first name column. So I run this. So it's executing, it just executed. So it created index. Now, as soon as it created index, and if I run the same query, you will see it took like 0.0014. It's a large improvement on how it is able to find that value in that 500,000 records that fast. Doesn't even have any query. And now if we do explain here, it will tell us how many records it went through. So in this explains query, as soon as I executed, it's saying type range. So type range is still better than going through all of the record and values. Now, it used that B tree index. And if you look at this, it has to process only one row. So I will go through the B tree structure in a few, but if you see, it had to go through one row to fetch that record. So it's a very large improvement just by building a nominal index. So we used the default index, we used on one specific column, and still we were able to improve quite significantly. Anyone has any queries till now? Yes, no?
I think there was a question in the chat.
John, will you be able to read the question? Sorry, I have so many
Can you
windows.
repeat what you just said? Difference between procedure and function? Oh, which John?
Either one.
Yes.
Either one, I guess.
Any John, either one works.
Any John.
So the procedure, yes. So procedure is basically, so function is a concept coming from functional programming languages, right? So function either can return a value, means I can say a function to return a value. Right now, it's not returning any value. It's just executing this, right? So it's a declarative statement, and it's executing it without returning anything. If I say, suppose, I don't know if any programming languages, suppose I'm defining const a is equal to, and if I'm executing function add something, 1, 2. So behind the scene, if I say this function is executing return 1 plus 2. So this const a. So after this, suppose I execute this right now, it will not execute here because this is database editor and database engine. So database aren't capable of executing this. But in programming language, how we do it. So now if I want to find a value, it will be 3 because this function, it executed and gave back this value. So it is returning something to the receiver. To this variable, you are assigning the return value from this function. So that's the function. Where also function can be even like this. I can just console log without returning anything. So function can be even like this as well. Where it is not returning anything, it's just console logging it, but then it doesn't make sense to assign it to anything. You can just have it run independently because here you're not returning anything, so you're not assigning any value to any variable. So function can be created both ways. Whereas procedure, the whole purpose of procedure is not to return anything. It doesn't return value. So that means you cannot consume that function in select query. So that's basically a difference. And this will be the, so mostly in general purpose programming languages, you will not find procedure. Procedure is concept belongs to mainly databases. And even triggers are concept belongs to mainly databases. Triggers, procedures are very native to database rather than programming language. Whereas function is global because every programming language has function. Their basis is function, basically. Even though Java is object-oriented programming languages, but still after you create the class, you have to define a function within that class, which is commonly used by all of the object when you create it for that class. So that's the difference. Any other question? Any other question in the chat?
No other questions in the chat.
Perfect. So here, this is just we ran to add 500,000 record because we didn't want to add this manually. Only that reason we ran the procedure. We will go into procedure and function again in detail, like close to the end of the series, where we will be covering all those type of things. Here we created the table again. As I had said, I will be always using varchar unless I know the length of things, and only then I will be using char to optimize the storage and database engine operation. So now we created 2 index here. The primary index, it basically came by default as soon as I wrote the primary key, which is clustered index. So as soon as I mentioned it as a primary key, database took this as clustered index and created this clustered index called as primary. Now this second index that you can see here is the index which is non-clustered index that I created manually just by writing this query. Create index and the index name that I gave, which is exactly here on the IFH employee table with the first name ascending. I can do descending as well. So what happens is it uses that and then it creates the index based on the values that you provided here. Again, I can use B-tree or I can use hash. But B-tree is by default, and B-tree is very optimized, so you don't need to go into generally using hash, and there are other methods as well. So in flat file, if I go here, hopefully this time I will be able to write it properly. So in flat file, even so when I did explain that query, it was telling me how many record it went through, right? So how many record it searched to find that value, which we can do again. So after building index, it went through just one row and it was able to find it. And if I drop index again, drop index, and I'm dropping index. So I dropped that index, means now I don't have index. So if I refresh this, so I just removed that index. This is just for test purpose. Now, if I run same query again, it will take large amount of time. If you see, it's like 0.28 seconds, whereas it was like 0.000, which was like a huge difference. Now, if I do explain again, it will tell you how many records it searched through just to find that. Even though if I do select on this table, the position of name 5 is 5th from the top. So, in general assumption, we will assume like it should find that very quickly. Why it has to go through all of this record? We know this because we created this, but machine doesn't know whether that record is only this record or there are any other records with a similar matching criteria. So that's why it has to go through all the columns just to make sure that there is no other similar matching criteria exist and can return the value. When you build index, because it sorts it beforehand, so it knows where to look at. So it doesn't have to like go through all of the values after that. Now we will get back to, so we discussed the binary search tree and the B tree. In most of the programming languages, you will see using binary search tree, but Y databases uses B tree. So binary search tree are like this. Sorry. And so it's hard to draw, but I'll try my best. Suppose that it's 7. This will be less than 7. This will be more than 7. Then we'll do, this is 8. And suppose we do this 11. So binary search tree properties are, it has like left half and right half. So this is like a right subtree and this is like a left subtree. So left subtree will be always less than root. So this is root. So this is root. So root will be always, so left subtree will be always less than what is in the root. And the right subtree will have the values which is greater than the root. So that's why if you see here in the binary search tree, which is BST, which is binary search tree, and then binary search tree has like a maximum of 2 children. So it cannot exceed to 3 children because that breaks the protocol which is defined for this algorithm. So it can only have at most 2 children, which is if you see the root node has, it can at most 2 children, but it can have less than that. So it can have 1 or 0 as well. So root has 2 children. And if you look at the right subtree, the subsequent children has again 2 children, which is 8 and 11, which is 8. If you look at, this is 9, 8 is smaller than 9. That's why it is on the left. And then 11 is larger than 9. That's why it is on the right. But then if you look at the left tree, there is a 4. This 4 doesn't have any children. That means it is still a valid binary search tree. Now in binary search tree, when algorithms search for something, suppose it has to find 8. Now it knows that it has to find 8 and it is already sorted in that order. So it will look into only this half. It will not go into the left subtree at all. So basically you are dividing your search criteria into half in each iteration. So you're saving this much amount of time whenever you're searching through the binary search tree. The problem here arises is, so this is valid binary search tree. Suppose it's 3, this is 4, 5, 6, 7, right? So this is root node. This is still a valid binary search tree because 4 is greater than 3, that's why it's on the right. 5 is greater than 4, that's why it's on the right. 6 is greater than 5, that's why it's on the right side. 7 is greater than 6, that's why it's on the right side. But if you see, this is unbalanced because now if you have to search value, you will have to still go through all of the data points. That's why it's called as unbalanced. And this is like a worst case scenario, and this is going to happen one way or another. So that's why in databases, we use B tree because B tree is a self-balancing tree. So B-tree, the criteria itself makes sure that it will never going to be in this worst case scenario. It will balance itself. So this is unbalanced BST. It's an unbalanced binary search tree. So just because of this reason, and also there are other multiple reasons we're going to interpret, there is a B tree. And also, as I discussed last time, so we have disk drives, which are basically spinning disk with the head in here, which reads the disk, right? The disk constantly rotates. And we have other RAM, ROM registers inside the CPU, which is kind of a grid. And each grid, sorry. And it's a very simplistic representation. Behind the scene, this grid is built with transistors, and then there are also registers. This is just the electronic representation of transistor and registers. So behind the scene, this RAM, ROM registers inside the CPU also latches. You might have heard of L2, L1 catch, L3 catch. That's where it plays important role. So this grid is a binary value, which either is 1 or 0, right? So that's how the machine stores the data. So each grid will have some representation of that binary value, whether it's a 1 or 0. And that's how it, very simplistic form, that's how it stores the data into the RAM, ROM registers, L1, L2, L3 catch inside the CPU. Sometimes L3 catches are outside the CPU, L1, L2 catches are inside the CPU. We'll go into that in detail later. But if you consider the disk drives, it's a rotating disk. And then there's a head which like moves back and forth to read that disk. And most of the computer you will see has this disk drive. Even if you open MacBook Pro, even though it looks very flat, nowadays it has other type of drives. But even if you take like 2018 before laptops, you will see like this is very compact disk drives. So this disk drives has like called as sectors and the blocks. And then these blocks, again, if you take one portion here, there are multiple sectors. And then it is becoming very complicated. But here, if I take this only portion from this specific sector, so this is a track. So each concentric circle is a track. And then this is a sector. So this is sector. This concentric circle is a track. And then if I want to read data from specific location, this is like a block. So this is a block. So in block level, where the data gets basically stored. Now, what BST does is, not BST, B-tree, because when we are using database, it will mainly use B-tree to store the data. And then also in here, there is a really nice website for B-tree visualization. Maybe we'll go through here. It will be easier rather than drawing on the notepad. So the B-tree properties are in the notes as well. So if you look at the README file, there are B-tree properties. There's a visualization link. You can play around with it. This is for the binary search tree. So although, again, we'll go into a bit, although indexes improve the performance, but too many indexes also are very bad, because every index that you create, it will have to modify this created index as well. So if I create this index, let's do this. So I created this index. Now database know that there is index exists, right? But this index has the values sorted in the ascending order of the first name. So whenever I add a record, means the database will have to modify that index as well to comply with new data that is coming in into the database table. Means having too many indexes as well can reduce the read-write speed. So you will have to be very cognizant while creating the indexes. So you will have to choose the optimal solution. And the optimal solution is whichever column you refer again and again in your query, in your data set, you will create index on those columns only. Don't create the indexes on the columns that you are not going to refer. It will be just overhead because database behind the scene will have to manage those indexes every time you insert the record, every time you add, update, and do some changes in the database table. Sorry. So that's basically overhead associated with the indexes. So create the indexes, the one that is you're going to use more often, and the tables which are columns which are you're going to refer in your where clause. So if you look at this in the where clause in this query, I'm referencing the employee ID column. That means I'm asking database to look at this and just look at this value and fetch the record, right? So that means I'm using employee ID column. Here in this query, I'm telling database, look at this column and fetch me the whole record. So if you're using any column in your where query, in where clause, then you should be creating indexes on this table. Now, if you have a small table with 10, 20 values, you shouldn't be creating index. It doesn't make sense. Indexes are basically if you have like, hundreds and thousands of rows, 10,000, 5,000, something even. In that, it will make sense, but for the small table, it's not worth it. So there is overhead associated with the index. This basically defines that. And then in a table, you can have only one clustered index. So whenever you define primary key, it creates the clustered index. And you can create non-clustered index as many as you want. So this primary key, it can be only one because primary key is kind of something, that's how it sorts it. And this is the secondary sorting that you are adding based on the first name, but this is happening secondary. So non-clustered index, you can have as many as you need, but the cluster index can be only one. That's the rule of thumb for any database and any database engine. It also tells here that adding primary key automatically creates the cluster index. Not the cluster index, you can create as many as you need. Again, the same thing, avoid creating indexes on the columns that you're not going to use that often. Here, so right now I created the index on the only one column. I can also create index on two columns. So this non-cluster index, here there's a first name. I can also do last name. That means I'm telling database to create index using these two columns, right? So now I'm creating a new index with a different name. I'm just saying its name. Because it's a combination of first name and last name on the IFH employee table, and use these two columns to create this index. If I run this, I create another non-cluster index. So if you see there are two more cluster index, I cannot create primary again because that's just one. It can be only one per table. So now there are two indexes, one with just the first name and the second with the first name and last name. And there is one thing here though, if I create index with last name in the first in indexes term, in mathematics, A plus B is equal to B plus A, so you can do BA, which is valid. But in index system, they are not similar, so they are different, right? So they don't behave the same way that A and B will behave. So they are different things. So, but I would always say if you don't need two columns, don't create two indexes. It's again wait for database engine to look into that, reconfigure itself whenever you do add, edit, update, delete commands. If you're querying with just first column, then just use that. But you can technically create a composite indexes with using multiple columns. So those are called composite index. And then also you can create one or more non-cluster index. Zero or more, technically you can have zero cluster index, or you can have 1, 2, 3, as many as you need. till the length of your column. The maximum limit is, I guess, 999 for non-cluster index, but also it may vary based on whether you are buying enterprise version or the community version. So, but 999 is the most common limit for the cluster and non-cluster indexes. So here again, I mentioned AB is not same as VA. You can have indexes on the temp table as well. You cannot have index on the view. So maybe I can save this later. Views cannot contain the indexes. So because view aren't designed that way. View supposed to not to store anything. That means you cannot create index as well. And in your queries, so we looked into the indexes and the benefit of indexes, but also there are a few other things that you can do. First, not using star, only referencing the specific column names that you want to pull, right? First name, last name, email, something like that. So when you use star, consider you have to bring all of that data into the processing memory. So it will, the database engine will call CPU, CPU will call L1 catch, L1 catch will call L2 catch, L2 catch will call L3 catch, and it will go to RAM. So it checks whether data is present in all these things. And if not, then it will go to the disk. Then from disk, it will fetch to the RAM, then L3 catch, L2 catch, and L1 catch. And then it will pass to the CPU for processing, which is overhead because you're asking it to bring everything and do the computation on it. So if you don't really need it, if you have like millions and millions of records, and if you want to just see what it has, how many columns it has, blah blah blah, then you can just do first name or something, last name for reference, and then call the query. It will be much faster than doing the star. You can see the differences if you even just now if you run with the star and without star. Also, the pagination concept. The pagination concept is derived from the same. If I have like 500 million records, but I don't want to look into all of them because only even if I look into 100 records, I will get to know the information that I need. Then I can always use limit to limit the number of records that I'm fetching, so that it's a less load on the disk as well, the CPU as well, everything which is getting involved to make this happen, and database engine as well. So limit is also your good friend. Mostly now this is focused on data analysts and data scientists. So these things does matter a lot. You have to pay attention to all these details, whether when you're running query, why it's taking like 5 hours to run it. Where you can improve it, whether the creating index can improve it, whether selecting the specific column can improve it, whether limiting the rows can improve it. This limit concept you will see in multiple places, even if you go to the web application. Maybe this is a production, we'll just go to the mock server application. My internet is running very slow, and my computer is running slow. Basically, my computer fan speed is way up high. So here, now see, there is a pagination at the bottom of the page. So this is pagination. Means I'm telling, and this system right now, we don't have more than 77 records, but technically what I'm telling is for each page, only bring in 100 records. So it doesn't have to like fetch all of them thousands of records in the system. That improves the application performance as well, and also the query performance on the database side. So the pagination here, I had set it to the 100, so that's why it's 77. If it are 100 records rather than 100, and 101 will have been in the second page. Even you will see the same thing on Google when you do the search. It has like pagination at the bottom of the page. Because again, all the Google has like billions of money. They can build huge data centers with a high compute, but still it's going through the billions of pages at a time to produce that result. So it still has to do that pagination to improve the user experience. Same as whenever you can do a job without fetching in all of the record, you should be always taking into that consideration. Now here, this is like database engines. There is a InnoDB and MyISM. You don't have to pay attention to this. This is like if someone wants to get into the details. By default, these two engines uses B-tree algorithm, and then memory and heap uses hash and B-tree. But you can force them to use different. So here it looks very weird because I guess I'll show here. That's a markdown language. That's why it looks different in editor, but you will see this in readme.md file. And then the B-tree properties is basically every node has at most m children. A leaf node with k children contains the key -1 values. Root node has at least 2 children, if not leaf node. We will do a very quick demonstration in that visualization website. Every leaf node except root has at least m/2 children, which is a ceiling value. And then all leaves appear in the same level. So here, this is B-tree. Now we are taking degree 4. Now, if I want to insert, suppose 0, 1, we'll just add record and see how it performs and does the operation. 2, 0, 3. Now, see, it has a degree 4. So I added 3. So degree 4 can have minimum at max 3 children. So means if I enter 4th record, it will divide that. You know, it's algorithm. So it's following this protocol. So it's basically following these protocols, and based on this protocol, it is deciding where to put that value. Now, if I do 0, 5, so now did you see it did some operation before putting that value, right? So 0, 5 was bigger than root node, and then it's also sorted here. So it puts 0, 5 here. Now, if I do 0, 6, now this node has reached the limit of the keys that it can store. So once I add this 0, 6, now what it did, it compared the leaf node. It already has reached its limit because it can contain only m-1 keys. It divided. Now again, it compared the operation. It moved the middle element 0, 3, 0, 4. Now middle can be lower ceiling, which is kind of floor. And then it moved up, and then also then it dedicated 2 leaf nodes, and it added the values. We'll just do a few iteration, and that's how it basically data gets stored into the disk. 7, 8, 2. So now here you will see one thing happening. See, why did it create height? So it increased its height to 1 level. It did that because the max degree 4 can only have 4 child. So as soon as it reached the limit of 4, it inserted 1 additional height, and then it rearranged itself into this arrangement. And that's how it is divided. It wasn't any magic. It's just following its protocol, which is defined here. So B-tree of order m can only have at most m children, which is it did. It basically created additional height as it reached that limit. And also it can have only m-1 keys, or we can also say a node with the k children can have only k-1 keys because it also varies based on this level. So whenever you are searching something, and if the indexes are built, it will use this structure to look the specific, whether it's a left tree or whether it's a left tree or whether it's a right tree. So you will see how much time it saves because it doesn't have to go through all these values because it doesn't matter. It's already sorted, database knows it, and then it will fetch the appropriate value from the specific place. You can play around with this. This is very nice website built by these people. It's in the documentation. It gives like very good view. Sorry, I've been getting Slack messages. This gives like a really good view of how that B-tree algorithm works. You can also try deleting the nodes, edges, and see how it behaves. and how it reorganizes. It does like a left rotation and right rotation to organize itself when you remove the node. Because whenever you remove node, it has to satisfy all these criteria again. It has to satisfy all this criteria again whenever you delete some node from here. So it has to reorganize every time you update, delete, or insert thing. And that's the weight, or that's the side effect, I would say, we have when we add the index. Now, maybe I will pause here for a few seconds. If you have any questions, please ask. I don't know if anyone typed any question in the chat. John, if you can read the question, if there is any question in the chat.
You want me to read it? We did it again. All right, John, you can read it.
This time, John.
Okay, I'll read it. Is it correct that difference between B tree and binary tree is B tree can have more than 2 children?
True, and it really depends on the order. So if I define B tree of order 3 or 2, then it will have only 2 children, right? Now that if I define B tree with order 2, that means that basically also binary search tree. So it depends on the order on which you define it. So here the degree is basically also order. Means, yeah, technically it can have more than 2 children, but also it depends on how you define the order. In database engine, it chooses that order based on the amount of data you have, and it will take the maximum order as possible because it wants to. So database engines have max 5 height. It doesn't go more than that. So if you have like millions of records, you will see that our degree and order will be like millions and thousands because it tried to reduce. So it also, so if you see every height means every travel, you don't want to do like, too many travels are one below other because it's again extra work. So database, it chooses the max value as optimized value based on the data as its degree. And then based on that, it creates the binary search tree. So B tree, yes, it can have more than 2 children, and that's how it came into existence basically. The Boeing Research Lab is basically, the scientists in Boeing Research Lab came up with this algorithm. Any second question? Is this answer clear? It depends on the degree you define. If you define degree of 2 or order of 2, then it will have only 2 children. So that means it is being kind of binary search tree. But in binary search tree, there is additional thing. In binary search tree, you can have leaf node in multiple level, right? So as I showed when I was drawing here, not here, the previously, let me see. So I'll just go through it quickly. Oh gosh. So there is one other thing that binary search tree has. So I'm drawing binary search tree right now, the one that I drew before. So here, this is leaf, right? This is leaf, this is leaf, and this is leaf. But if you see, the leaves are in 0 height, 1 height, 2 height. So leaves are in 2nd height and also in 1st height. This is not allowed in BST. In BST, in B tree, all the leaf node needs to be in the same level. So this all leaf node, the tree will have to reorganize itself. The tree will have to reorganize itself to contain those children on the same level. So it has to have children's leaf nodes at the same level. So that's another thing. Is it clear? I don't know who asked this question.
Yep, thank you.
In binary search tree, you can have, leaf node in any height. In B tree, you need to have leaf nodes in the same level. And that's the protocol for the algorithm.
No other questions so far, Dinesh. No other questions so far.
Okay, sounds good. Okay. So we've been through this. So the links are already provided. You guys can go through and play around. Now we'll go through some other topics. So the title of this series was DML queries and DDL queries. So when I did this, is DDL query, right? So when I did create table, means I'm defining the table. This is data definition, right? Whenever I'm doing create database or drop database, this is technically DDL query, means I'm defining the structure. Anything that defines the structure is DDL query, means data definition query. Anything, now if suppose here, what I'll do is even alter, right? Alter table, I'm altering the table structure. So I'm basically working with the table structure. So whenever I do alter, it is also DDL query. So creating a table, altering a table, dropping database, creating database, all these are data definition queries because you are creating the structure and creating the database. Now, if I want to update IFH EMP, set name is equal to, I'm just changing this name 5 to name 55. I guess it might exist. So we'll do 545, where first name is equal to name 5. Now here I can do this update query two ways, whether this is a match criteria. Now this is matching based on this criteria. Let me drop this both the indexes. I will drop this second index as well. Okay, so now here the matching criteria I'm doing is first name, and then I'm updating this record and setting the value as name 545. Let's see. This is just specific related to databases. If you're using MySQL Server, you might not need to do this. This is very specific to MySQL. So here I'm telling it is safe to update. It's a transaction. So that same database table value may have been accessed. There might be, you have 10 different users coming to your website. They might be accessing the same value. So database tries to prevent it. It basically either you can use transaction where you can preserve the atomicity of the value. So you can do like something like begin transaction, and then you can do commit. So this technically tells database this is safe to update. Whereas this also tells the database it's a safe to update. That means I'm telling forcefully database, and no one is using is, please update this and it's safe to do so. So I'm doing this. So it updated. So one row is affected and that value is affected. Now this value I updated where the first name was name 5 and which is exist with in this column, right? So if you see, I just updated this table value to 545, which is on the 5th level. So this is basically DML query. So whenever I am working with manipulating data, that's a data manipulation language. So update is, alter is not, because alter, you are altering the table structure. But update, insert are basically data manipulation queries. So again, there's one thing we weren't able to cover last time, but let's go through that. I will update the title of this day 3. It's kind of misleading. So in day 2 command, let's go to the SQL queries. Here, there are 2 tables I created, and then you might have seen this start transaction and commit, right? So let's run this. And I'll tell you why it is, because now it's relevant. We do Stick this. So this is, I'm creating kinship table, and then it has basically kinship ID. Now here it's auto increment, means for this kinship ID, I don't have to tell, like here I was telling like use 1, 2, 3, 4, 5 to add into ID column. Here a database will automatically figure it out because it will use this auto increment algorithm and increment value by 1 automatically. So that's the use of auto increment. Now I'm creating the second table. Here, you will see, now we have all these two tables here. So we have IFAG employee table, then kinship and participant. So if I run this, right, I can technically do this as well. I'm inserting here, I'm inserting only values in this column. Let me see if I did auto increment here. It has auto increment, then it might not take. It should be fine. It's because it's not the participant ID. I will have to remove this. So okay, maybe we'll just run this and you will see the error. So if I do this, so it didn't add it because also the foreign key and also because of the participant ID is auto increment. So let here because it's auto increment, if you see, I'm just adding value for kinship name, so which is just this column, right? Let me add this. So I didn't do here like this, kinship ID, and then 1. So I didn't do this because it's taking that auto increment and figuring out itself and doing the addition and all that. So this is here, it will take care of it. It should be backtick. Or you can write this without backtick as well. You can just skip it as it is. Backtick is up to you if you want to use it. If you don't want to use it, it's completely fine. You can run like this as well. And then when you are inserting the values here, it's an integer. That's why I'm entering the number. And whereas this is a varchar, which is a string, that's why I'm using single quote. I can do this as well like this. Now, because it has auto increment, it will not take this. I'm using father, mother, let's say grandfather, right? So if I enter the grandfather is already there. Now I'm not using here backtick and in both the places for the table name, but it still was able to enter it and inserted one value. Now if I do select star for this table, also right now I'm just running this in the small table. You shouldn't be doing select star, be cognizant on the state. So it incremented that value automatically because it was set to auto increment, and that's what it is basically. Now here I have auto increment set. When I define this table, I define it to auto increment, not null. Again, primary key column cannot contain null values. It is not allowed. It's basically no, right? So any other column can contain null values unless it is defined as a constraint. So here, unless I define the constraint, basically not null, right? It can contain null values. So, but by default for primary key, it will not accept null values because it breaks the protocol on which this is all designed, even the algorithm. So not null will be by default. So I can just ignore it. And then whenever I'm mentioning this as a primary key, this column by default will not accept null values. I will go back here, participant ID, I set to auto increment. Now I will have to, suppose I run again, this time it will not show the foreign key stuff. So okay, so it had set to the non-auto increment, but it can again fail this constraint if I do increment because that already value exists. right? So now this already exists. I will have to increment that value. The purpose of transaction here is to why now we'll come back to the transaction here. Now, why the transaction? Suppose now I enter this value with the ID 1, and then I entered this second record, third record, and then I committed. Let's see. So I can do this as well. It will enter the record just fine. But whenever I entered this, so I entered this record, it created the index, right? Because it has index defined, it has primary key defined, it also has foreign key defined. Now I inserted the second, so it has to recompute that index. So it says now you have like 3 records here to insert, which is very small. And then if you have more millions of rows to insert, then recreating index every insert is not feasible. Right now it looks very fast because we are able to insert, we have only 3 records and it's inserting very fast. But every insert command, it rerunning that B-tree algorithm to update its index. So it's like an additional computation it has to do. So in such a scenario, because you will be using that with the thousands of millions of rows. So in such a scenarios, even when you do the programming, when I write a web application or even mobile app, it will. So if you are using ORM, the one the last time we defined, which the Hannah asked, ORM by default, that's the benefit of ORM. It begins the transaction and it commits it, where commit means end the transaction. So what it will do is for all this insert, it will not recompute the indexes. It will recompute index as soon as it hits this last point. And that is the benefit of mentioning begin transaction and the commit. So as soon as it hits the last point, it will go and then start computing the indexes. It will run that B-tree algorithm and create the index rather than recomputing it again every insert value. And that's the benefit. And you should be using this as a best practice whenever you are working with thousands of records, millions of records, to save the execution time, because that execution complexity will increase if you don't use this. So this is your friend, basically. Maybe what I'll do is I will delete this. And then we can insert maybe similar records, except this. Let me see. So email is unique, so I will have to change email. There are a few constraints I defined. So unique is a constraint, means email cannot be duplicated. So I guess there is no more constraint, so I can remove this. And I will have to update email if there is email I defined. Let's do this. And let's see. So if you see it, started the transaction, it executed and commit. Now here, after the commit, it went to that re-indexing stuff and did the index. On the primary key auto increment, there's one thing I forgot to mention. You can insert yourself a key, but then you will have to keep track of that auto increment. So the best thing to do, and it also depends on database to database. MySQL will let you do it. You will have to look into the other databases as well, where Oracle lets you do it. But then in that scenario, you will have to keep track of the primary key. But it's always a good idea to let database handle that increment rather than you manually inputting that value, because there might be collision. Collision means having similar value you're trying to insert which already exists in the index. Any questions here? We are very close to the our session. Any questions? Any questions in the chat?
No questions in the chat.
Okay. So here, maybe I will quickly go through 2-3 variations you can do. If you do default null or null, it will be the same. It doesn't matter. It's just a nicety that you can say default null. Also, you can define character set here. I can define character set, which character set it should use. But defining character set on column level is bad idea. Defining it on the table level, it's okay. And this is, it's okay to define it, and then it's globally applies to all of them. And there are different character sets, UTF-8, UTF-16. Right now, for example, I do this without dash. So defining character set, there are in the notes, the day one notes, you will see there are characters set defined here. I did add that on purpose for you to practice. You can define character set on column level. You can define character set on table level. Also, you can define character set on whole database engine level. Means there are default config parameters that you can set. Just like when you set config parameters for your web application, look at last time when we looked at that ORM database configuration values, it was globally applied to whole application. So similarly, you can apply that global values, means when database starts, as soon as the database starts, it will look into that configuration values and it will take that and apply it to its currently running instance. So you can set character set on the column level. I would say it's really no, unless you really need to do it. Apply it either table level or apply it on the whole database instance level, so that it's consistent across. Because if you have different character sets in different column level, consider the computer has to do additional calculation just to figure out what's going on. It's a machine; it has to follow each step, and if you make it burdensome, it will take more additional time. So whenever you suppose you receive a large bunch of data set, try to make it consistent across. And if you use UTF-8, any Unicode character set except ASCII, I might be pronouncing it wrong. Any Unicode character set is fine. Don't worry about it whether it's UTF-8, UTF-16. Although regularly, if you look at the operating system, they usually use UTF-16, but UTF-8 is fine. Because if you do UTF-16, again, the byte size that it needs to store in the database, it increases. So unless you are utilizing it, you don't really need that much byte size for each column row value to put in the machine. So UTF-8 is fine. I would say be cognizant what you're doing. Reiterate, revisit things. If suppose one query is taking, like for web application, the ideal is like not to exceed, I would say 30 second, 10 second. For bigger data sets, I would say reevaluate it when you run query, revisit it, look into what else you can do. Use char only whenever necessary, use varchar always. Also use constraint only when it's necessary, because whenever you create constraint, I guess that's something I can show you right now. So when I said email as a unique, when I look into the participant table, you will see index created with email. So means that unique key also creates the index. So when you define the constraint, be cognizant when you're defining the constraint, because it is adding the index. So unique, foreign key, primary key. By default, they create the index. So make sure you're also cognizant and aware of that, and even when setting the values. And that's pretty much for today. I will quickly update the file name for day 3 series. But everything, all the notes, do's and don'ts, B3 protocol are in day 3. And we will go through the joins and others and next query, next session, so that we can go more in depth and handling null values as well. Any
Thank you,
questions?
Dinesh.
There are 5 messages I had to. Okay.
Mostly thank you.
Okay. Awesome, great. Also, beyond this, as Marie said, we will look into creating Slack channel. We will see the pricing for this. If not, we'll create the teams. And IT team is very open. You can email us anytime. Even if it's midnight, we will reply. So feel free to ask questions. And then, later, maybe as Hannah asked, we already covered that thing, how application utilize it. We can, again, revisit it for the ORM communication, how you can build your ORM itself in application level. Great, and thank you so much for joining, everyone.
Thank you.
And we'll see you next session.
Thanks.
Thanks a lot, Dinesh.
No problem. Take care. Bye.
All right.